Hello friends, so today we are going to discuss another LeetCode problem, and the problem title is reordered power of 2. So it's a medium problem, so let's get into the problem description. So here we are given an integer as an input, and what we have to do is we have to return either true or false, but based on what? So basically what we have to do is we have to check whether the permutations, not the permutations, we can say like combinations of the given numbers digits is a power of 2. If it is the case, then we can return the true, else we have to return the false as a output. So let's quickly look at the example part. So in the example 1, if we can see like 1, so of course like 2 to the power 0, it gives us the 1, so that's why the output is true. Now if you consider the 10, so if we form any kind of combination, one more thing I missed here. So like whenever we form the combinations, and if the combination starts with the 0, so we have to neglect that combination, because 0 1 is not a valid combination. So it is given in the problem statement. So like it says, like starting with a positive integer n, we reorder the digits including the original order such that the leading digit is not 0. So the digits combination which starts with 0, so that we have to skip. Now next, the example third. So it's straightforward. Like if we 16, so basically if we 2 to the power 4, it gives us the 16, like it gives the true output. Similar for 24, because if you form like the combinations of 24, either it can be like 24 or 42, but there is like no such digit or no such number, I would say, is a power of a 2. So that's why it returns false. Now coming to the last example, that is a 46. So 46, again like straightforward, 46 is not the power of a 2. So if we reorder the digits, so the number becomes 64, and the 64, it is like power of 2. So that's why the output is true over here. Now one more thing is important over here is the constraint. So constraint is like it is given, so 1 is less than or equal to n is less than or equal to 10 to the power 9. So I will let you know why this constraint is important. Now let's get into the coding part. So here, like straightforward, if we see, so we first thought we can get is we have to form, like we have to split the number and get the digits. So that is the step number 1 over here. Now in the next step, what we have to do is we have to start from the power 1, and we have to reach, or we have to keep moving forward until we meet this criteria. Once the counter reaches to the 10 to the power 9, and if we don't find anything or any such number which has the similar set of digits for the given number, so in that case we have to return false. But if it matches, then we just have to return the true. So I will now jump into the coding part, and it will be more easier to understand what I am trying to explain. So here the function name is given as reorder power of 2. So it accepts n as an integer input. So here what I am doing is, initially I am forming the original hash map based on my input number. So this get digits function, what it does is, so this is a very basic logic I am performing over here. So I am iterating through the number as long as it is not becoming to 0. So whatever, like let's say if it is 10, so my hash map becomes 1, 0. If it is 16, then it becomes 1, 6. So similarly for like 2 digits, 3 digits, and like many more digits. So based on that it forms, or it splits the number into the separate digits, and it forms the hash map based on their splitted values. So that's the whole idea here. So I'm storing it in the original hash map. Now what I'm doing is, here I'm taking an integer variable. So initially my pointer starts from 1, and every time what I'm going to do over here, I will do the left shift operation by 1. So when I perform the left shift by 1, so it will keep on increasing the so basically what happens over here is, let me explain this. So let's say whenever I do this operation, okay, so initially let's say my x is 1. So whenever it performs the left shift by 1, so it becomes so basically it increases the power. So the value of x becomes 4 over here. So again, like if I do the left shift by 1, so x becomes 8, and this way it will keep on increasing. So that's the whole idea over here. So what, like I have to perform this operation as long as I don't reach to this value, that is the like this is the selected value or the highlighted value. It represents the 10 to the power 9. So that's the constraint is given over here. Okay, so this is the constraint. So we have to keep looping through it as long as we don't reach to that 10 to the power 9 value. Okay, so here is the left shift operation. But meanwhile what we have to do is, for every power of a 2, what we have to do is we have to check, let's say when it is a 1, so what is the hash set. So hash set is for 1 is 1, so for 2, like it is a 2. If it is 16, then again 1 6. So what happens is, let's consider this as an input, so it is a 16. So in the original hash map we get the value as a, here we get the hash map value as 1 and 6. Okay, so next time when we check it for 1, then 2, 4, 3, 4, then 8, and finally it reaches to the 16. So here the current hash map value becomes 1,6. Okay, so finally what we check is, this is a simple check whether the original hash map is equal to the current hash map. If it is the case, then we can say like we have found the power of a 2 for the given input, and simply we return the true value here. And if it is not the case and we reach to the threshold value, that is the 10 to the power 9, and in that case it will simply come out of this while loop and it will return the false value over here. Let me quickly run this program and I will show you the output over here. Okay, so here we have got the success, and the solution runtime is 5 milliseconds. Now coming to the test case pass, so here it has passed all the 135 test cases, 135 test cases over here. So now coming to the time complexity and the space complexity of this algorithm. So here what we can see is, we are using the 2 hash maps over here. So it's kind of the big O of n we can consider in terms of the space complexity. And again, like we are iterating through the number for the first time, that is a big O of n as a time complexity, and again for the next to calculate the we are iterating through this while loop till the we reach to the threshold value. So again that is the power of big O of n we can say. So the overall time complexity here is big O of n plus 2 to the power n over here. So that's the whole idea over here. And if you have any doubts or if you want to have any suggestion, so you can post it in the description comment section, and I will reply over there. And if you want the full solution of this algorithm or this problem, so you can check the description section. I have uploaded the solution on the GitHub, and I have posted the link in the description section below, so you can refer it. And if you like this video, please do like it, comment this, and subscribe to my channel, and please hit the bell icon to get the more updates. Thanks for now. Stay tuned for the next one.